Hello, everyone. This is the pre-recorded lecture for week 3 for applied statistical analysis. Today, we are going to be going over a little bit more terminology, and then we're going to get into central tendency, variability, and then we'll finish with talking about confidence intervals. So to start, these are two words you're going to hear quite a bit in science: reliability and validity. Reliability is about the consistency of the measure. How consistent does it actually measure what it's trying to measure? Validity is, does it actually measure what we think it measures? Looking at these targets below, we have this one on the left. All the dots are really close to the center and they're close together. Here's one, they're not close to the center of the target, but they are close together. This one, they surround the center of the target, but they're far apart. And then this one, they're far apart and not centered around the target. So just take a sec and think about which one of these, is this one reliable? Is it valid? And do that for each of those. So how'd you do? So this one is reliable and valid. It's reliable because the points are close together, and it's valid because it's centered around the target, what we want. This one is reliable. The points are close together, but it's not valid. Conversely, this one's not reliable because the points are really scattered, but it is valid. It does surround the target. And then this last one is neither. It's not reliable nor valid. It's not centered around the target and the points are really scattered. So the question then becomes, how do we know? Because usually we don't know where the target is for sure. We just want to know, is our measure good? Is it reliable and valid without actually knowing what the real thing is? So with reliability, we usually use something like a factor analysis. It involves correlations. We're not going to cover that much in this class. Correlation we will get into. We won't talk about it in terms of reliability very much, but it's just fancy correlations that people will generally use to test for reliability. And then validity, it we usually compare with correlations with things that it should correlate with or shouldn't. And it's often very much based on theory. So for example, if we're building a measure that's trying to measure depression, there's other measures of depression that it should correlate with. So we can correlate, if it does correlate, then that's a positive sign. We also may know, well, maybe depression is supposed to correlate with anxiety. And so our measure of depression should correlate with a measure of anxiety somewhat. So both of these, they're never going to give you a final answer, but they can give you an idea of how well your measure is actually getting at what you want it to. So one thing that's nice about reliability and validity is that they are so important that usually when someone is coming up with a new measure, they test these things as much as they can. Now, reliability, it totally depends on each sample. So when you do a study, you would need to know how reliable is a measure with my sample. Validity, on the other hand, is usually across the board. Once they can show that it is a valid measure, then it's usually something that is assumed across the board. Although there are times when that assumption might not be met. Regardless, both of these are going to come up when you are writing about any study that you're doing. You're going to want to address these if you're using any measure, especially measure of uh, psychological, emotional, mental states. Those are very hard to measure, and so these are usually things you're going to have to talk about. So some more terms: correlation versus experimentation. Correlation is more observational. You're not doing any sort of treatment or intervention. You're not really making anything happen to anything. Experimentation, on the other hand, you are doing something. So there's some sort of treatment, there's an intervention, there's some sort of a manipulation that is impacting some people and not others usually. The best way to actually do experimentation is if groups are randomized or conditions are randomized in some way. So you have correlation on one hand and experimentation on the other. Some things to consider are what are the pros and cons of each? Both can be used, and they are used if you look in the literature, look at studies done in your area. Both are going to be present. When it comes to correlation, it is cheap. It's often a lot cheaper to get correlational data than experimentation data. It also can be ethical. For example, uh, all the studies done with smoking basically had to be correlation because the scientists understood that smoking probably caused problems. And so it would be unethical to say, okay, you random group, you need to smoke while another group, you don't smoke. So experimentation in that case is just not all that useful. Another thing about observation is it's very natural. We don't get into this a whole lot in this class, but in other classes you may have talked about it. It's very externally valid. It generalizes to a lot of to real life. Experimentation sometimes has a problem with external validity. But experimentation, when done right, it's very, very good at showing causal relationships. It's far more controlled. Uh, Problem with that is it can make it so it may not generalize to a lot of real life situations because it's so controlled. So both are very useful. Depending on your research question, it helps you determine which one is the most useful for your situation. It also depends on the field how often each are used. So it's possible but difficult to convince causation with correlational or observational data. It's possible, but it's very difficult. You may have heard this first saying correlation does not imply causation. So if there's a relationship, that doesn't necessarily mean that one causes the other or vice versa. However, people often ignore that correlation does not imply it isn't causal. In other words, if there is a relationship, there could be a causal relationship there. And so on your end as a student, it can be really easy to say, well, correlation does not imply causation, so the study is garbage. If you're going to say that, you need to have good reasons why you believe it's not causal. All right, so that is it for just general terminology. A lot of those things are going to come back. We're going to use a lot of those as we're talking about specific methods that we're going to use. So keep those in mind. Make sure you understand those well enough that when they come up later on, you're not like, what? Okay, when it comes to central tendency, the question is, what does this mean? And I think that's kind of punny because one of the measures of central tendency is the mean or the average. That is one measure of central tendency. Where's the middle? So the average is one, the median's another, and the mode. And we usually just have these three. So when we're talking about the mean, it's the arithmetic average. You sum up all the scores and divide by however many scores you have. The median is the middle score. It's the number where half of the scores are above and half are below when they are in order. The last one, the mode, is just the most common score. So which one do you see the most? So it depends on what kind of data you have that'll determine which one of these is most useful. So the mean, you're going to need interval or ratio data that are roughly normally distributed, which is kind of a bell curve where it's symmetrical on both sides. So you don't have really extreme outliers on one side or another. A median you can use with ordinal data. and with interval ratio data that are kind of skewed or have weird outliers. We're going to talk about this more in our in-class discussion. With the mode, that can be used with nominal data. It's the only one of the three that can be used with nominal data. The other two need some order to the data. I use this term, outliers. It's just it's just a term that means points that are far from the other points. It doesn't mean they're bad or wrong, it just means they're far away from the others. So computing the mean, I know many of you are not super comfortable with equations, but all this is saying is you sum up all of your x values and divide by however many you have. So the sum of the scores divided by the number of scores. When it comes to computing the median, the first step is to order the values from lowest to highest and then find the middle value. So when you have an even number of values, there's going to be two of them that are in the middle. When that happens, you take the average of the two middle ones. So for example, if you have four numbers, we'll just say 1, 2, 3, 4. The two middle values are 2 and 3. Neither of those is more in the middle than the other one. So we would take the average. So the median of 1, 2, 3, and 4 is 2.5. The median of 1, 2, 3 is just 2 because there is an actual middle number there. And then when it comes to the mode, you just find the value that is the most common, and that's the mode. Here are some practice situations. We're going to go through this pretty quickly. If you have questions, make sure you post it on the discussion board. So mean, median, and mode for age. Age looks like a continuous variable. It's just numbers that look like they range from 21 to 33. So the mean is going to be just summing them up. If you sum them up, you get 213. And how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So you divide by 8. So the average age is 26.6. When it comes to the median, we can sort them in order. So if we put them in order, it's 21, 21, 22, 25, 28, 29, 33, and 34. Okay, so there is a 34, yep. So because there's 8 values, there's 2 in the middle. So 25 and 28 are middle scores. So we take the average of those, which is 26.5. And then the last one, the mode, we're looking for the most common one. And in this one, as you'll see in a lot of continuous variables, the mode is usually not, there's not usually a whole lot of repeating values. And so the mode is often just something that's 2 or 3 times repeated. So this one, there's 2 of 21s. All the rest are just in there once. And so the mode is 21. All right, so what about the mean, median, and mode for degree? So the first thing we want to think about is what kind of variable is degree? Does it look continuous? Nope, so it's definitely not interval or ratio. So the mean is scratched off the list. And then is there an order to it? Can we consider this ordinal? And so at first glance, maybe we think, yeah, there's an order to it. But the question is a master in science or a master of education, which one's higher of those two? Probably neither. So this one is just purely nominal. There's no order to it. So the only one that we can use is the mode. The mean, there's no value that it doesn't work with nominal data. Median doesn't work with nominal. So the mode is just the most common of these, and that's the Masters of Science. All right, so we talked about the central tendency. Where's the middle of our data? The next question is, what about the spread of the data? So we may know where the middle is, but we want to know how far does it spread? How much does it range? What's the min? What's the max? Those kind of things. So in this distribution, This is called distribution because it shows roughly where people are at. So the median and mode are right here. The mean is right here if we calculated it here. So the question is, how much does it actually spread? And that is actually the term variability. So we want to measure this somehow. We have measures of central tendency. Do we have measures of variability? And the answer is yes. So there's two in this class that we talk about a lot. There's going to be an additional one that we introduce later on. The first one is range, and that's just the max minus the min. So how much does it range? So if we go back to the ages here, it went from 21 to 34, so it'd be 34 minus 21. And so the range would be 13. The other one is a standard deviation. This one is really important. When it comes to the standard deviation, it's a typical or standard, that's the term, distance each score is from the mean. So you can think of it as the average deviation from the mean. So how much do each of the points, how far away are they from the mean on average? That's what the standard deviation is. So when can we use either of these? Well, with range, we can use it with ordinal, interval, or ratio. The standard deviation has to be interval or ratio. So ordinal works with the range. We can say, like, if it's places in a race, so it's first to 10th place, we would say it ranged from first to 10th place because we can't really minus those very well. With standard deviation, it just doesn't work. It only works when the mean works. So if the mean works for something, the standard deviation will also work. So when it comes to actually computing the range, the two approaches I've mentioned already, it's max minus min. So at the ages, we did 34 minus 21, so we got 13. The other way is saying the min value to the max. So we'd say it ranged from ages 21 to 34. When it comes to the SD, this equation might make you feel a little uneasy. That's okay. I'm going to walk through the pieces just so you understand what the pieces are. In general, you're never going to have to compute this by hand. That's not what this class is about. But I do want you to know what the pieces are. So when you think of the standard deviation, it's essentially the average deviation from the mean. How much each individual point, the x, so the x is here, from the mean, whatever the mean is. So all this does is it finds all the deviations, adds them up, divides by how many there are, and takes the square root after we've squared them. So all it is really, it's an average. So when you see an SD, you can think on average, so let's say the SD was 5. We would say on average, the points were 5 units away from the mean. So if it's 5 years with the age example again, it's essentially saying on average, people are about 5 points away from wherever the mean is. So that gives us an idea of the spread in the data. That spread would be smaller than if I said the SD was 10. That would tell you it's even wider. People are even further away on average from the mean. But make sure if you have questions that you post it on the discussion board. So other things to know about the standard deviation. First, there is a population standard deviation that's denoted with a sigma. It looks like a cursive O. But it's usually unknown. We usually don't know what it is, but it exists. It exists out there. If we could measure every single person in the population, we could calculate the standard deviation. We usually don't know it. So RSD is usually an estimate of the population standard deviation. And just like other estimates, we don't always know how good it is. But if we collect our sample correctly, according to statistical theory, it should estimate it pretty well. All right, so I told you we're not going to calculate any standard deviations by hand. So we're just going to look at the range of age and grade. And do this really quick. The range we talked about, 34 minus 21 is 13. The other way of saying it is 21 to 34. And then I could ask, what is the range of grade? So A, B, and C. So we would say the range is from A to C. We could also say from C to A, either way. All right, so our last topic of this pre-recorded lecture is the confidence interval. This one is going to be important because we're going to use it in a lot of other situations other than just what this example is. But I want you to be able to understand it because it combines information from the central tendency that we talked about and then the variability, which is the standard deviation. So let's say on our number line here, we are talking about the average hours of Netflix per night. So in the number line, I go to -3, no real good reason, just for fun. 0 up to 3. We would expect the average hours of Netflix per night that individuals are watching is probably greater than 0. Let's say this is the true population value. We don't know it, but this is where it is. So we'll say it's whatever that value is right there. So we get a sample, we go out and say, okay, let's ask everyone in our class how many hours they spend watching Netflix. And so this is our estimate right here. So that's our mean, probably somewhere around 1.5-ish. But because our sample's mean is just an estimate of the population mean, the other thing we should inform of is how much uncertainty is there in our estimate. And lucky for us, we don't have to be like, well, we're kind of confident or use words that we use in regular English. We actually have measures of how big our confidence is, how confident we are. In general, what we're going to use is what's called the 95% confidence interval. So let's say this is our 95% confidence interval. This is our upper bound is what it's called. And here's our lower bound. So a 95% confidence interval will contain the true population parameter 95% of the time. Let's say we did 20 samples across the university, and we got a confidence interval and a mean every single time. 95% of those would actually contain this true value. So if we have 20 of them, that means one of them, it wouldn't actually contain the value that we hope it would. But the other 19 actually would. So that's why we say we're 95% confident here. So this green area is the interval that shows the uncertainty in our estimate. We're saying this is our best guess right here, our mean, but we know it's just an estimate. So we're 95% confident that the true value is somewhere between here and here. The way to interpret that is we are 95% confident, so I put values on here, that the true population mean is between 0.75 and 2.0. So just by communicating that, we're already saying we know it's just an estimate that we have, but we're 95% confident that the true population mean is somewhere between here. The way we actually calculate this is we have our estimate, which in this case is our mean, and then it's plus and minus how much uncertainty there is. And the uncertainty depends on the standard deviation or a measure of the standard deviation and the confidence level. So in other words, if you have a bigger SD, you're going to have a bigger interval. So the SD, if it's wider, that means we're going to be less certain about where things are at. With this in mind, the estimate, we would say to get this lower bound, we would do estimate minus this uncertainty. That would give us this value. And then we do estimate plus uncertainty, and that would give us the upper bound. The most important thing to understand with the confidence interval is what it means and why we use it. So again, it is an interval that helps us understand the uncertainty in an estimate. We're going to use this throughout the semester, not just with means, but with other estimates too. And it basically always has the same interpretation. We're always trying to describe where the true population value could be with the information that we have. Final note about this is you probably have seen this in a lot of polls. They'll say the margin of error. Generally, the margin of error is an estimate of a confidence interval. That would say, let's say the average was 2 and it was plus or minus 1 point, then it would be, our confidence interval would go from 1, that's 2 minus 1 is 1, to 3, which is 2 plus 1 is 3. We use this all the time when we're actually collecting information. So next time you see a poll and you see some margin of error that they're talking about, think, oh, that's just telling me about their confidence interval. And generally, the margin of error is based on a 95% confidence interval. They usually tell you if it's not that. All right, so if you have questions, please post them to the discussion board before class starts. This is the end of the pre-recorded lecture slides. We're gonna come back to a lot of this. This can kind of be the first challenging lecture in this class, trying to understand what these concepts mean. And so please ask so I can prepare for it and have the lecture ready for you for in-class discussion.